So now we're going to switch to, let's see, close the notebook for a moment. Done with transverse wave notes, done with 3.1. Let's look at homework 3.2, electromagnetic waves. In the 1880s, Heinrich Hertz, that's where that name's coming from, Hertz, performed a series of experiments with electricity and magnetism. He observed that energy could be transmitted from one coil to another through electromagnetic waves. So, electromagnetic waves, again, this is code for light. And here's the electromagnetic spectrum. This is pretty much exactly what we have in the notes. Starting out with a very long wave, getting shorter and shorter all the way to the end. So just like before, our longest waves of light are radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma. Now visible from here to here, just this little teeny region that it shows it like expanding so we have more space. That space there is all that we see in the whole world, like right there, blick, just that. And in that we can see, let's get some colors, red, orange, yellow, green, blue, darker blue, purple. And you've got the whole rainbow. Now when I put these together in order, I have to keep track of what, I can't just put a rainbow, I have to actually orient it correctly. This side over here, UV is ultraviolet. I wonder what side of my rainbow should be on the ultraviolet side versus the infrared side. So put red closest to red, red, orange, yellow, that's really bright yellow, green, blue, indigo or whatever, darker blue, and violet / purple is here on the side of ultraviolet. Rookie mistake, if you get your rainbow flipped and you've got purple next to infrared, that's not going to work. So number 1, label the types of label the different types of electromagnetic radiation above. Include the colors red, orange, yellow, green, blue, indigo, violet in the visible light region. So, all done with that. Electromagnetic waves or electromagnetic radiation is described in terms of its wavelength. Yep, got that. Frequency. Oop. And a new one that we haven't talked about this yet, but it's also going to be defined in terms of energy. So usually with energy, if I can find the correct marker, can't find it. Okay, so usually with energy, I will be color coding energy in orange, but again, we're not quite there yet. So all we're worrying about right now is wavelength, frequency, and we recently learned that the speed of light, letter C, is 2.998 times 10 to the 8 meters per second. Our equation, C equals wavelength times frequency. So energy is actually on the back of this paper. We're still working with this same equation from the notes. All right, let's try a problem. First off, pause this video. You definitely need a calculator. I will be using, I prefer to use the graphing calculators, but I'll also grab a regular calculator from my classroom so that you can see how to input on those as well. So pause the video, grab your calculators. So here's the ones I have in my calculator, the TI-36X Pro. If you'd like, you can hit mode and have it in normal mode or scientific mode, either one. And just so you know, you're going to be typing in this number a lot, 2.998 times 10 to the 8th power. So just knowing how to do it, 2.998 times 10 to the is going to be, let's see, let me zoom in. It's this symbol here, X with the box. Click it, and what it'll do is put a little teeny boxaroo up there for your exponent. So 2.998 times 10 to the 8, and then hit the over arrow, boop, to go back down to like regular font if you want to put this in. I usually will put it in parentheses, like 2.998 times 10 to the power of 8, boop. There we go. I automatically put everything that has an exponent in parentheses because I don't want to get it wrong, and that's the easiest way just to fix it. Okay, so the problem says, Miss Oliver's favorite color, ooh, I wonder what it could be. I wonder what my favorite color is. Has a frequency of 5.17 times 10 to the 14 inverse seconds. I need to determine the wavelength of this wave. My equation is going to be C equals this, copy paste. C is always 2.998. Let me zoom in. 2.998 times 10 to the 8, I just plugged that in for C, equals, I don't know the wavelength, I'm trying to find the wavelength, so I'm going to leave the symbol, wavelength times frequency, it says it's a frequency of 5.17 times 10 to the 14th power. And I'm trying to rearrange this so that my final answer will be wavelength equals something. So I need to divide that over. I'm going to first do it here on this calculator because these are the ones I have in my classroom. 2.998 times 10 to the 8th power divided by 5.17 times 10 to the 14th power equals, now see here, this number is in regular notation. I have a preference usually to have my calculator in scientific mode, so that way when I do the calculation it brings it up with exponents. So I'm going to go with this answer, 5.7, I should round that, 5.80. E means times 10 to the negative 7th power meters. This calculation, this equation always needs to have meters thrown into it. Meters need to go in, meters will come out. But the problem wants us to figure out, to see what colors correspond to each wavelength here. So if I pull up this chart though, I can tell I already need to convert to nanometers. Let's learn how to do that. So if I have this wavelength, I'll do it off to the side here. 5.80 times 10 to the negative 7. Let me just show you what the answer is going to be and then also how I got there. So here's the final answer. 580 nanometers, that's my favorite color. And if you go to this link, you follow that through, you'll see that 580 nanometers corresponds to a mustard yellow sort of color. Find your favorite color. Then you can be that nerd at the parties that's my favorite color is 580 nanometers. But here's what we're basically doing. We're saying 1 meter is equal to 10 to the 9th nanometers. We have a ton of little teeny nanometers in one big meter. This is our conversion. I have 5.80 times 10 to the negative 7 meters. And there's 1 meter for every 10 to the 9th nanometers. Punching this in the calculator. 5.80 times 10 to the negative 7 times 1 times 10 to the 9th divided by 1 equals 580. The way that I do it is a little bit of a cheater way. I usually will just look at my numbers and go, oh, a nanometer is 9, and this is negative 7. 9 minus 7 equals, I need to move the decimal 2 places. Whoop, whoop, move it twice, and you get 580. That's how I do it so quickly whenever I've got these sorts of calculations. The next question here says that a laser emits a frequency of this. What is the wavelength of the light in nanometers? So this is the exact same question. You're trying to find the wavelength, convert it from meters to nanometers once you have an answer. And using this same chart, you can see what color of laser pointer this is. So pause this video, go through, and see what you get for this. there's my answer in meters. I want it in nanometers, which is 9. I'm going to move the decimal 9 minus 7. I'm moving the decimal 2 places. So instead of having 6.32 times 10 to the negative 7 meters, I'm going to have 632 nanometers. Here's that on the calculator if you want to see it. I'm going to take 6.32 times 10 to the negative 7, multiply it by 10 to the 9th power, because it's a nanometer. That's 632 nanometers. And just for funsies, like I said up here, my favorite color was golden yellow. Checking out that same link, what color is this laser pointer?